Hello! Haha! Surprise! Fantabulousness! Welcome to the Hub Lab, where we are going to do some experimentation. Sent in to you questions that have been sent in to us via the rte.ie/learn or by the PO box with on post. People have been sending in some questions. Actually, some people have been sending in some pictures and some jokes. In fact, I was talking to some people the other day and they were saying, why did the picture go to prison? Because it was framed. See, I love these jokes. Keep sending them in because it makes me look hilarious, and then you can tell them to other people that seem hilarious as well. Thank you to everyone in Alexandra College for giving me some jokes the other week. That was very useful. What I'm going to talk to you today is a little bit dangerous because we're dealing with some fire in terms of candles. So no matter what happens, I know we say all the time that you can try this at home, but this stuff you only ever try when you're with a responsible adult. So, first experiment that we're going to do today is about candles, different heights, what they produce, and actually how they can be extinguished. We've done an experiment before a while back. You remember we did it in the dark kind of room where we made CO2 with baking soda and vinegar, and it was nice and heavy and it sat down the bottom of a jar and we were able to pour it over things and extinguish it. Experiment that I wanted to do today was I have 3 candles, a tall one, a small one, and in the middle one. And what I'm going to do is I'm going to light these 3 candles, and then I'm going to take this and put it on top of it. And what I want you to figure out, or have a guess, is what candle do you think is going to go out first? Which one's going to go out second? Which one's going to go out third? Are they not going to go out? Are they all going to go out at the same time? We've had some predictions here in the crew. They think various things. We've had one strong vote for all at the same time. We shall see. So first things first, again, responsible adults, never on your own. Don't do this, not even joking. Here we are with this. So we've lighted 1. Light 2, so fire, you need oxygen, fuel, and heat. Put this on. Yeah. Okay, so what's being used up? What's being produced? Where is it going? What's it's undergoing? So we'll have a look. Let's see which one. Do we think it's going to be the top, middle, bottom? Watching, top is getting, is it? No, is it? I don't know, top's getting, it's going down. There we go. So they kind of went out almost simultaneously. Top slightly ahead of it, then this one, and then the bottom one is still lighting. Now, if you said that you thought it was going to be the bottom one because the carbon dioxide is heavier and normally sits at the bottom and then would fill up and eventually put it out, that's a great guess because you would remember that the carbon dioxide is more dense than oxygen or than air and would have naturally filled up the bottom. Now that's a good guess, but what's actually happening when you produce carbon dioxide with a candle, it is heated, it's hot, and things that are hot are less dense than things that are cold, so it rises up to the top and the carbon dioxide actually fills from the top down, which is why it goes out, and then this one would eventually be the last one to go. So you'll see that from this, we're talking about what's inside air. And we talk about carbon dioxide, we talk about oxygen, and we talk about nitrogen. Carbon dioxide, there's only a little bit in our air that we breathe. But oxygen is about 21% in the air that we breathe around. And we need oxygen to produce to breathe fire or anything else, but we wanted to know, is all of the oxygen used up when you burn something? So we had a little experiment I'm going to show you here now that will show a little bit about oxygen and what it produces, and do we use all of the oxygen up in as we burn something. So I'm going to take a little bit of red food coloring, I'm going to put it into the water here and give it a stir so you can see it more easily, and pour in here. So we've got red liquid water into there, and now we'll put this on top, but I'm going to put the match on top here and see. So what we're going to do is we're going to burn the oxygen in our atmosphere and see if I put the glass up underneath it, what happens to it. What do you think is going to happen? It's a nice little experiment. See what you think is going to happen. So if I start burning, and then I put this on top of it. It's burning now. There's bubbles coming out. It's burning away. It's using up the oxygen inside. It's producing carbon dioxide. But look what's happening. The glass is sucking up all of the water. Now, why do you think that is? Is it because it's using up the oxygen inside and it needs then to replace that, so it tries to suck in oxygen from outside to bring in, and that's where the water gets sucked up? Or is it another kind of thing? Now, if we said, and we've read in books and other places, that there's a 20 to 21% oxygen in our atmosphere, that means that there's about a fifth of our atmosphere is made up of oxygen. So 1/5, if you were to split out into 5 even parts, oxygen would be one of those. Is this a fifth of this glass? It doesn't kind of, looks a lot less. A fifth would be kind of around there. This looks about maybe a tenth of it. So, you know, is it about right? Let's try it with something else. What could we do to figure out this a little bit more? Well, maybe if we burn 2 matches, it would use twice the amount of oxygen. So let's see if I do that. 2 matches side by side. Like that. There you go. I put them on top. So now, yeah, bubbles, bubbles, bubbles. Burning, using up the oxygen inside. It's producing some carbon dioxide. Now what happens? Blah, 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 blah. It's sucking up water. And it's sucking up a little bit more, but not much. Okay, so nice little experiment. Now, you would think, like, when you've got matches in this, that it is using up the 20 to 21% of oxygen in the air, and then that is why it contracts and it sucks in the water. But that's not what's happening. This is not an experiment, a measure of the amount of oxygen in the air, because when you burn something, it is replaced by carbon dioxide. Not exactly, but roughly around the same amount. What's happening in here is that the matches, the fire from it is heating the gas, pushing, expanding out the air inside it, pushing away, and then when they go out, it causes it to contract, cool down, take up less space, and that's what sucks in the water as you go. So if you're actually to hold the glass over it a little bit longer, heat the air a little bit longer, and then just time it right, you should be able to get all of the water inside. Go out there, try things, research, find the facts out, find your answers, find out what you like, and give it a go. And send it in to us at rte.ie/learn. We'd love to hear from you. See you next time.